This is our second video on two-variable statistics. Suppose we're given this data and we are asked to linearize it. Let's go through the steps. The first step is we check to see that both data sets are on the increase, and that is not the case here. This mass is increasing, but the acceleration is not, and that isn't going to work. The way you solve this is you take the reciprocal of every value that's in the decreasing data set, and you make a new column of data with the reciprocal of everything that's up here. My new data column is going to be 1 over the acceleration, and the unit for that is going to be seconds squared per meter. I've taken the reciprocal of both the variable and the unit so far. Now we take the reciprocal of each of these values, and I've taken the time to do that already. 0.05, reciprocal of 10 is 0.1, obviously. Reciprocal of 6.7 is 0.149. Reciprocal of 5 is 0.2, obviously. Reciprocal of 4 is 0.25. Reciprocal of 3.3 is 0.303. And the reciprocal of 2.9 is 0.345. Once we've done that, I like to put a little line through that data set so that I'm not tempted to put that into my calculator now. So now we check one more time to make sure that both columns are on the increase. Looks good. Now we look for linearity. We look for proportionality, you might say. And so here's how we do it. Mentally, mass goes from 1 to 2. That's a doubling. What about over here? 0.05 to 0.1. Hey, that's a doubling. All right, so far so good. Let's check another one. How about 2 to 4? That's a doubling. And here, 0.1 to 0.2. Oh, that's a doubling. All right, one more if you want to really cover your bases. How about 3 to 6 is a doubling, and 0.149 to 0.303, that's a doubling, isn't it? Because this is about 0.15, and that's about 0.3, and that's a doubling. All right, so far so good. Now we need to decide who needs to go in the X values column and who needs to go in the Y values column. And the way you do that is you look at the units and you decide, in terms of physics, does it make more sense to have kilograms on top and this seconds squared per meter on the bottom, or does it make more sense to have this be the rise and the kilograms be the run, right? Because slope is rise over run. Well, what we're going to do is you perhaps will recognize, and the more experience you get with physics, the better you'll be able to recognize this, that the kilogram meter per second squared is the same thing as a Newton. You might have run into that when you've studied Newton's second law, if you have in any previous physics course. So a kilogram meter per second squared is a Newton, and that means if we have kilograms as the rise and we have that column as the run, if you take kilograms and divide by this, I hope that you see that you get the unit kilogram meters per second squared, which means these are going to be our Y values in our calculator, and these are going to be our X values. All right, so let's put those into our calculator. Sneak that over right there. We're going to go into stat mode. We're going to hit edit, and we're going to put our X values. It's very important. You put your X values in the L1 column. You put your Y values in the L2 column. I've already done that. Now we need to quit this by hitting second quit. Now we need to go back into stat. Now we want to calculate. So we toggle over to calculate, and the choice we want here is the fourth one down, linear regression. I've already arranged my data sets the way I want them, so I don't need to fiddle with this screen. I'm just going to hit enter a few times until we get to the results. Boom, there you go. So here's the equation. Y is equal to 20.1 x minus 0.01 3. Now, don't stop there, because what we need to do for our final answer is to put the actual variables that we have in the problem. And the y values were mass, and mass is m. The variable for mass is m. So don't put y here, put m. And what about x? Well, x are these guys here. X is 1 over a. So can you see that 20.1x is going to be 20.1 over a? There you go. Now, very often what will happen in a physics question is they will ask you something about, hey, what's the average net force on this mass? And what you then need to do is you need to look at your linearized data and see if you can match it up with some physics equation that you know. So you see this y-intercept is a really small value. So basically this equation is m is equal to 20.1 divided by a. And with a little experience in physics, you will start to relate, oh yeah, there are some important equations that probably match up with these data. And so m times a is the net force. So if they were to ask you, hey, what's the net force on this mass? You'd say 20.1 and you'd put a unit there, newtons.